Hi again, welcome to Walt 1. I can solve simultaneous equations using the elimination method. I've got two examples that are here. You'll find them in your booklet. So if you don't know what it looks like, there it looks like. Flip it open. You'll find these two examples here. So one there and then a paired problem you can practice. And then of course one here is the other example and another paired problem that you guys can practice as you look through it. And flipping over of course, then basically we're going to go to here today. And so if you want to know what questions we require of you, it's these ones that are just sitting right here. Okay, so let's get into this. And let's start talking about a few things. So if we have a look at the two equations that I have here, I've got x plus y is equal to 3, and I've got x minus y is equal to 1. Now the problem is I can't solve this because unless I know what one of them are, I can't work out the other one. You can't work out two unknowns. So if I said that x was equal to 2, then of course we can now know that y has to be 1 because 2 plus 1 is equal to 3. But without another equation, I can't actually do that. So what I need to do here is I need to get rid of either my x's or my y's here. Now I'm going to do this question twice because I'm going to get rid of the x's first, and then I'm going to show you that you can do the question exactly the same way by just getting rid of y. Okay, so over here I'm going to start with x. So what I'm going to do is pretend that these are like a big sum. And I'm going to take away. So x takes away x, or how many x's do you have after you take one away? You have 0 x's. And you'll notice now that I have managed to eliminate, oh, you can't see that, but I'll write a bit closer. Eliminate x, or get rid of it. Okay? Then I've got a little bit of a tricky problem, but I'm going to do down this side here because I'm going to have y take negative y. Now, if we remember our time on the number line, and if I draw a very quick number line down here, remember that this is our positive direction and this is our minus direction. So we have y, so that would be positive y. So I'd face the positive direction and go 1y. So there it is. And then we have a minus y. So what do these say? Well, this one tells me to face towards the negative direction, but this little fellow up here tells me to walk backwards. So while I'm facing that way, I'm actually going that way. So I end up moving backwards this way or in the positive direction. And so sometimes you'll find that maths teachers will say that y minus minus is the same as, and remember I use the equal sign to show that they're the same, as y plus y. Now it's not real good to remember that a negative and a negative make a positive because then you don't actually understand what's going on when we move along here. But we've done enough today to be able to know that y plus y is going to be equal to 2y. So that's 2y. And then, of course, the last bit is don't forget the numbers. So 3 take away 1 is, of course, 2. So how do I solve for y? Well, 2y means 2 times y. So I'm going to divide by 2 because I only want 1y. I don't want 2. And those 2, well, 2 divided by 2 is 1. And 1 times y is y. And then, of course, if we divide on this side, then we definitely need to remember to divide on the other side as well. So in this case, we've got 2 divided by 2 again, which we know is 1. So I have found a value for y. It is 1. Now, if I looked at this, I would probably say, okay, if y is 1, so if y is equal to 1, then x plus y is equal to 3, and I told myself that y was equal to 1. So, can I work out what x is? Well, of course I can. I just need to get rid of this plus 1, so I'm going to do the opposite of adding 1. I'm going to take 1. And I'm going to make sure, of course, that as I always do, I need to do it on both sides of my equal sign. So 1 take 1 leaves me just with x on this side, and 3 take 1 leaves me with the number 2. So what have I actually worked out? Well, if I drew this on a set of axes very, very quickly, then at the point where x is 2 and y is 1, these two lines meet. Or we call it, if you remember from the last video, a point of intersection. Now, of course, I don't know what the graphs look like. I could find out quite easily by rearranging and graphing this, but in this particular case, I don't really want to. I just want to know at what point do they intersect. Now, if I was going to write this as a point, I would need brackets, 1, comma, 2. No, I wouldn't, because that would be wrong. Tricked you. I would need 2 dash 1. Remembering, of course, that x is always first and y is always second. So don't forget that, or you might make a silly video. Alright, so we got rid of x in this case by taking. But what happens if I add them together? Okay, well, x plus x gives me 2x. And once again, I come down to one of these questions where I've got y, so positive y in this case, plus negative y. So if we look at this, and we might use that number line down here to help us again, it says to face in the positive direction and go y, like we did last time. Excellent. But then it says face in the positive direction, so we're facing this way. I'll draw that. We're facing this way, but then it says that it wants us to walk backwards. So we're here, but it wants us to actually go backwards. So this plus and this negative here are actually making us walk in the negative direction. So I'm going to just rewrite it like that, just to make it a little bit easier, because instead of 2 symbols, it's just 1. And of course, y take y is equal to 0. So we've worked out that this is equal to 0. So in this case, we have eliminated y. So if we took, we got rid of x. If we added, we got rid of the y then. So then, of course, the last thing, don't forget the numbers. 3 plus 1 gives us the number 4. So 2x is equal to 4. Now, if that's the case, of course, we can divide through by 2. And x becomes, so 2 divided by 2 is 1. 1 times x, is equal to 4 divided by 2, which of course is 2. So I now know that these points meet at when x is equal to 2. Well, that's funny because I already knew that, because this is actually the answer for this question. It's the same question, aren't they? So if x is equal to 2, then x plus y is equal to 3. We replace this x with the number 2. So 2 plus y is equal to 3. And then, of course, we can do 2 things. We can inspect this. So in other words, we can just look at it and go, okay, well, 2 plus 1 will give me 3. And therefore, y is 1. Or we can use our linear algebra skills we learnt at the start of the year. And, of course, this is positive 2. So I'm going to do the opposite, take it away. And this is, of course, going to be 3, take 2, which gives us the 1. So now we already know this was the answer, because that was the same question. But we had a choice, and this is the interesting thing. Sometimes in mathematics we don't always have a choice, but in this question we were given a choice about whether we wanted to get rid of y by adding or to get rid of x here by taking. Now we come and have a look at this question. That choice has been taken away from me because I've got a 2x and a 4x, and I've got a 3y and a 3y. So this question is set up for me to eliminate y, not x, because no matter what I do, if I go 2 take 4x, I don't get 0. If I go 2x plus 4x, I don't get 0. So in this case, I'm going to have to get rid of the y's, and it's because they have the same number. All right, so let's see what we're going to do. So I've got to do 3y, or positive 3y, something, negative 3y, and that needs to equal 0. So we go back to our number line again. I know you hate it, but I love it. So we're going to go back and remember a new number line for us. So this says go 3 in the positive direction. So I actually need to go back this way, but I've got to walk backwards to get there. So I would have to be facing this way to then walk backwards to get myself back to 0. And that way, of course, is the positive direction. So I can put a plus in there. And of course, we know from before that we're going to face the positive direction but go backwards. So we're actually facing more or less in the negative direction. And that's going to give me 0. So a lot of things there, but we worked out that the symbol we need to put here has to be a plus. So 2x plus 4x is 6x, and 3y plus negative 3y, we already know is 0 because we worked it out. And then, of course, we've got 13 plus negative 1. So we add them together, we get 12. And the final answer is 6x is equal to 12. So, how do I solve this? Well, I'm going to divide by 6 and divide by 6. 6 divided by 6 is 1, and 1 times x is x. 12 divided by 6 is 2, so x is equal to 2. So, now I know x, it doesn't really matter. I can put them into either of these equations. Now, I'm going to put 1 here and 2 here, so I can put down what I'm actually going to do. Probably should have done this in these ones, but we're just learning, so this is the technique that we would like to see from now on. So, if we think about it, we can put it into either equation 1 or equation 2. Now, I'm going to pick equation 1, so I'm going to substitute. Now, I'm just going to write substa, put a dot. X is equal to 2 into equation 1. Okay, so I'm kind of listing what I'm doing, which is always good, especially if you're doing it for your teacher. So 2x plus 3y is equal to 13. So, which one do we know? Well, we know that x is 2. So we know there's a times between here. So this is going to become 2 times 2. We just replace that x with the number 2. Plus 3y is equal to 13. So 2 times 2 is 4. Plus 3y is equal to 13. So I'm going to take 4 on both sides, the opposite of 4. And by doing that, I'm going to get 9 and 3y on this side. Of course, many of you have probably already seen the answer, but I'm going to divide 3 by 3. 3 divided by 3 is 1. 1 times y is y. And of course, 9 divided by 3 is 3. So where do these guys meet? Well, they meet. So therefore, these lines meet at, and of course, we need to give the point. So x first, so 2, followed by y, 3. So you don't make an error down here like I did before. Okay, guys, so that was the elimination method. I'm going to make probably a couple more videos, but that's the basic explanation for the elimination method. If you're still struggling, then come see me in class. But from this point on, I'm going to make some more videos about the elimination method and what goes on when different things happen around here. Okay, thanks, guys, for listening. I know it was a long one, but hope you're studying hard. Bye.